Hi guys, today I want to show you something really cool. Let me set the camera up so I can show it to you better. There we go. I mentioned a little VU meter and I got it, and it's hooked up to a power supply, and these two other wires wrapped around here is for audio connection. This is the one that's already calibrated for the application. The other one they have is the same. It's not calibrated. It's the only difference. And here's a Dunkin' Donuts packet of sugar. Just to give you an idea how small it is. It'll sit easily inside. If that was as I mentioned before, a matchbook box, it easily could fit inside that. So if this was a box like a matchbook, it fit inside here. The only thing that would stand out a bit is the terminals. Clearly, if you're finished in designing a circuit around it, you can remove that, desolder, and solder wires directly to the board. And you can see it's pretty simple. It's got a 5-band resistors on it. You can see it. There's a capacitor. And yeah, there is the potentiometer. The potentiometer is the part you're going to be adjusting to calibrate this source to your load. I did find the schematic for this, so you can actually, and I see it looks like there's some additional holes. Yes, there is. There are some holes here. Can't really see much where to go to. Yep, this one goes to the 3 pots. So if you wanted to make this pot removable, you can desolder that and get an equally appropriate pot and connect that here. You can see the earth wire, and you can see the audio lead right here. Yeah, that doesn't go to the pot though. But what's neat about this circuit is it's very small, and it's pretty good. Thank God it doesn't have any blue LEDs. It's got green ones, but I noticed that whoever saw this connection didn't really line up the LEDs as well as they could do. As you can see here, they kind of have different heights to them, but it works pretty good. I jokingly said you probably could install this in a microphone, and you could, but you would have to adjust the pot really low to deal with microphone voltages. Well, this, I said, this one's calibrated already, so I don't want to mess with my calibration on it. This is calibrated to the specifications for the at 1.3 volts for positive 3 dB. Let me tell you what the lights are here. Obviously, when there's no lights on, it's 0 dB, or I mean minus, pretty low minus, it doesn't say what. Here is your 0 dBs. When these 3 lights are lit, this is 0 dB, this is positive 3 dB, and this is positive 6 dB. This circuit allows you to, you can hook it up to a higher level source than your standard connections of, but this seems to have a very high impedance. So when I built this jig here to test it as per Sure Manufacturing, using a 650 ohm resistor, because that's what I had, I found out that the voltage level had dropped enough that the meter was having a hard time getting a good peak. So I found out the best way to fix that was to do the test without this hooked up, because this apparently has its own loading. And when I did that, I got up to 0.3 volts, and I could see one of my leads broke off. Oh well, that's okay. I might want to remove this resistor anyway for future testing, but for now it's fine. Actually, I don't even know if I even said that, but that's okay. This is not a very bad little circuit. I can put this in the M68 relatively easy. I can mount it right above the master control. It would have to be mounted upside down. I'd have to put some hardware to attach at a right angle board to this. It would obviously be over everything, including, of course, the transformer, which is bad because that's going to increase. It's going to induce AC hum, and the lowest setting. This thing is extremely sensitive to AC hum. Not at all good. But if you're using it in a shielded environment, ideally away from power transformer. Maybe if you were to mount these over the volume controls, everything but the master control, it might work good, but I don't really want to butcher up my M68 mixer. So what I might do is, I got the other one, is I might just go ahead and pick up a small plastic radio hobby box and mount these two stack on top of each other for right and left stereo. Or I might do instead is, because I'll have a room in that box to install the bigger one, I might get the 9 LED version instead to give me more precise tuning. Or I could even go with the stereo bar graph one, which is a simple DIY circuit you solder together. Or I would rather have an analog VU meter. I did find several schematics for building one. The circuit from the M67 manual is very typical, using analog movement, using a rectifier bridge, a capacitor, and a resistor. The capacitor and resistor are used to make sure that the meter isn't too fast in attack and decay, which is really important if you're trying to read something. So the right resistor and the right capacitor is going to give you the right amount of swing. And the funny thing is the schematic shows that the resistor and the capacitor should be mounted before the input stage. So, in the case of this circuit here, it's a little different setup. I didn't take a reading on these resistors. It's got a component here. I don't know if it's, let me see if I can see if it's, oh yeah, the power supply I'm using for this is from the portable disk drive unit. Yes, I can read the number on it, sort of, except I don't have a zoom on this thing in video mode. Anyway, I do have a zoom in other mode there. Turns out this is a very common circuit, like Big Clive has pointed out on many. Can you focus on me a little bit? That's better. Okay, this is a very common circuit design, not very specialized. It's a SIP. For the price I paid, and it was pretty quick to get from China, and it works fine. I noticed a lot of kit words got these little screws. It uses a little jeweler's Phillips screwdriver. I don't think it can use a flathead, a Phillips. At least I don't think so. Maybe. Let's see if we can get closer to the holes. You can see the screws. Yeah, you might be able to use a flathead screwdriver in that, but good luck trying it. And as I said, it's pretty simple, really. And it works. So, calibration, pretty easy. If you are going to do what they suggested with the Shure meter under load of 600 ohm impedance, you may find it harder to calibrate, especially for some things. But I got it calibrated fine without the load. But obviously, if I hook a low impedance load to this, I'm going to have to adjust that little pedal again. You don't want to keep my connections the same. So what I could do is, some people like to put VU meters in their stereos because of the cool factor. Well, you can do that. You certainly can put this in your stereo system, and it will work great for that application. And you can also, I would recommend installing it in the line level circuit of the stereo amplifier, not in the power amp output, for two reasons. The first reason is that it means if you're going to put it on the power amp output, depending on the amplifier you got, you're going to have to turn this pot really high to avoid overwhelming the meter. On the other hand, if you're going to use it on the line level, once you got a 1 kilocycle tone, sinusoidal wave is preferred. That's a standard for adjusting these. You can actually adjust it using your voltmeter. It turns out my meter is accurate enough to do voltage. I had it wrong because I was testing it on the 600 ohm load. The output impedance of the Shure M68 is 2500 on the high output range. So that's on the line level is 2600. I don't think the output connection. You know what? I'm not sure about that. That's a good question. I mean, I use the same meter. I don't know if on my XLR plug does line level output. I know that the high output plug does. I'll have to check the schematic again to make sure, because I don't think it does. But anyway, this is the circuit for you. Very simple, very cheap, about $8 US. This will get you going. Buy two. That's what I did. And they don't come with instructions, so consider this your instruction manual. When you first get it, you're going to be fiddling with this knob. Unless you just want it for cool factor. Okay? If you're not going for accuracy, that's up to you. I set this calibrated this thing exactly to the audio standard. So this is calibrated down for exactly 1.3 volts to represent 3 dB and 1.6 volts represent 6 dB. And 1 volt even represents 0 dB. This is calibrated. So, I'll say the power supply, this will run on 5 volts. It did say that, but I'm running it on 12. You can see that's why I have these two wires. This is a 3-wire power supply. The blue carries 5 volts. I'm sorry, green. I know, I think it's a lousy color choice. I didn't come up with the color schema. I don't know why the factory that designed this power supply chose green, but they did. I cut the wire short on this because I didn't need a big long cord to be used for this. Now, to put this into a mixer, mixer like the M68, the internal bus mixer is about 25 to 28 volts DC. So you're going to need a 28 volts to bring it down to about 5 volt, or about 10 to 12 volts. You're going to need a 1K resistor in series with the plus sign, and obviously it's designed for negative ground because the ground circuit is minus, it's not positive. So if you have a positive ground application, well, then you're going to have to come up with some isolation circuits to prevent blowing everything to kingdom come, or have an independent power supply. Very nice little circuit for the price, and it's very useful too. I don't know what else you can use it for besides audio, but since technically a VU meter is a very precise voltmeter, once you got it calibrated, you could use it to measure AC voltages from, well, pretty low to pretty high. Obviously, you'll need to change the understanding of what the numbers mean so that the LEDs would mean different things. Like, for example, this LED here, when these three are lit, that's 1 volt. This is lit, this is 1.3 volt, and this is lit. All these are lit, that's 1.6 volt and higher. So you will just need to adjust it for that. So yes, you can use it as a voltmeter as well. My next project is to get the analog one. I just hooked the wires up in a quick and dirty way. It's not really best wiring, but okay, it works. Okay, and there you go. So if you need a meter, if you need something simple to do, easy. You can even make one yourself. The schematics are on the internet. If you want to make one from scratch, if you want to make this homemade jig like I made here, if you're going to set up by Shure specifications, you need about 650 ohm resistor, or 600 ohm exact. The closer you can get, the better. And then you hook your audio source in line level, and you would set the voltage of the output, which comes out of these two leads here, to 1 volt peak to 1.3 volts alternating current, because there's a 1 kilocycle AC sine wave, and then you calibrate the meter that way. that if your impedance in the input stage is different, you're going to need to adjust it. I'm sure didn't mention that, but that's how you do it. So, good luck with your experiments with little boards. And I should show you, I didn't bring it out here, but I should show you my homemade doohickey power supply, which isn't really too fantastic. It's just using 4 shockety diodes and a wire and a rectification bridge, and it's a full-wave rectifier with a 1000 microfarad 50 volt capacitor. The output voltage is about 38 volts. Yes, that's when, before I put the bleeder resistor in, that thing, that capacitor will hold a nasty zap for quite a while, and so I put a 1 mega ohm resistor in that. That was built entirely just out of scrap, not a drop of solder used. I'm sure ROHS would love that, right? Just all twisted together. That was just because I didn't know if I was going to make it keep it as a permanent little doohickey or if I was going to just use it for testing. And it does work, so I might just go ahead and use the finished project that I built and possibly as a low voltage filtered power supply for both the filaments and the bias, the minus 25 volt bias on the system, and that would be pretty cool. And then you would just adjust the bias to bring it close to where it should be for the 6BM8s or some of the other tubes that use a separate bias circuit to do the work. But can't go wrong. Want some cheap stuff, you want something to start with, please to play with. I like these connectors the best because these are the ones I was going to use for the original Fire Nice amplifier. We just ended up using them for this circuit because I had some of the RCA jack panels laying around for the original. These are vintage, new old stock. But for now, give you some idea to try for the future. See you later, guys. Bye-bye.